All right, so we're going to look at the components that form the Docker's ecosystem and the workflow. So let's have a look at that. So if you want to run Docker on your system, what all do you need is what we're talking about. Let's say on the left hand side, we have a Linux host. On the right hand side, we are going to run Docker Linux containers on Windows or OS X. So what do we need? First thing that we need is a Docker client. Docker client, when we run Docker commands, I showed you an example of running a container. So whatever I was running, I was using a Docker client, which allows us, which is a utility which allows me to write simple Linux commands such as Docker container run, start, stop, image create, and work with the Docker agent or Docker server rather. Right? Docker server or Docker engine is the interface that we were talking about, which sits on top of the Linux kernel and makes it possible to run these containers. And Docker client talks to the Docker engine over the API, RESTful API. Generally, it works over a port 2376. That's a Docker engine port, and Docker engine then translates these commands that we provide into what Linux kernel understands, and Linux kernel then provisions these containers, what we call as containers really. And that's all you need if you are running this on a Linux server. Now, when you run this on a Windows or OS X machine, one of the important aspects of Docker versus VM to understand is with VMs you can run hybrid operating systems. On a Linux server you can run Windows OS or a Solaris or some other OS as well. On Mac I can run Linux or Windows and so on. That's because it's hypervisor. It emulates the hardware. That's the isolation that it provides. Now when you talk about container, as we talked about, it's the shared kernel. It's the operating system level virtualization. So you have to use the same operating system. Now it is possible to run, let's say, a Debian or a CentOS or a Oracle Linux on top of OpenSUSE or CentOS or CoreOS, because if you look at the differences between the distributions of Linux, what we call as distributions of Linux, if you look at that, all of those share the same kernel. So the kernel is same. Kernel is what Linux is. On top of that, you have shell and the rest of the utilities which differentiate between different distributions. Now, talking about the kernel, since it is the same kernel, we can share or run Linux containers, different distributions on top of other versions of Linux. But we cannot run a Windows container on top of Linux and the vice versa. And that's where if you have to run a Linux container environment on Windows or OS X, you have to create some sort of virtualization, hypervisor based system. Now, when you use Docker Toolbox, it sets up the VirtualBox. When you use Docker for Windows, Docker for Mac, it actually creates its own, Docker has created its own layer of hypervisor around it, right? And it's a very thin layer of hypervisor. In case of Windows, I believe it uses Hyper-V as well. So that's what happens. So you have to have a Docker host, which is a virtual machine. And on top of that, you start running your Linux container environments. Now, when you talk about the Docker workflow, it works this way. So Docker workflow is when we actually launch and build our containers and so on. So what happens is you have Docker client, as we talked about earlier, which talks to this Docker engine, and Docker engine is the one which is going to launch our containers. So to run the containers, you need the environment, you need the images, and that's where the registry comes in. So we've looked at the registry, which is Docker Hub right here, and this contains repositories of images of different application or different types, right? And that's what we were exploring. So these are all the applications or different types of images which are available on the registry. This is a public registry called as Docker Hub. You can also have your own private registry. Docker offers you a solution to do that. That's called as DTR, or Docker Trusted Registry. Or you can use open source applications such as Harbor, which is a very popular alternative to the DTR. Now, registry is important because that's how we share our images with. And when you ask Docker to run or create a container, it's going to go to the registry and fetch the image. And the workflow is similar to Git. So it's going to pull the image and make it available locally. And using that image, it is going to launch a container. That's what we do. So container is the runtime instance. Container is the instance of an image. Image is static, container is dynamic. And using the image, you create a container. It's not the other way around. It's the image which is needed to create a container. And then you start making changes to it. Let's say you install your application or make changes or run it, or process something. And if you make a change and if you want to commit it back and convert it into an image, you typically have to commit that. Just like Git, you commit that back into the new version of that image. And commit is a local commit. So it is going to create the new version locally. If you want to push it back to the registry, you have to use docker push command, just like how we use git. So git pull, make changes, git commit, git push, and that's the workflow that we use. Now this is an imperative or a manual approach, and this involves a lot of manual work. So you're doing everything, launching the containers, making changes, and then committing it. If you want to automate this process, Docker offers you a way to do that. And just like a make file, you can write a specification file which is called as Docker file. Now, the concept of Docker file is very similar to the make files. The only difference is with make files, we define how to build an application from the source code. Here we are defining how to build an image from the source image that you would have and the steps to do that. So you write all these instructions, create a Docker file, and feed it into the Docker build process, which will help you automate this complete workflow. And that's the Docker workflow that we typically use, right? So we launch containers, we make changes, we commit it, we use Docker files to build the new versions of the containers. And what makes Docker a very interesting proposition is it's not just Docker alone. It's not just the way you run the containers. It's the complete ecosystem which is evolving around it, which includes the build tools. Let's say you want to automate the process of building the images. You have tools such as Docker Compose. When you want to run it and deploy it at scale, you have tools such as Kubernetes and Swarm and Mesos, and you have service discovery mechanisms and so on and so forth. When you want to distribute this image, you have DTRs and trusted registries and open source alternatives. When you want to manage this ecosystem, this Docker installation and orchestration, you have tools to do that, such as Rancher. You have tools for managing storage and data. You have tools for creating network configurations. You have monitoring tools and so on and so forth. So the complete ecosystem is what is offered, and that's why it is called as open container ecosystem rather than just a Docker ecosystem, as as I would want to call it. And there is a link to the Docker story at the bottom of this page, so definitely go and read about it. That's a very interesting story about Docker actually, and the way it evolved. And he is Solomon Hykes, the CTO of Docker. And if you look at his T-shirt, it does not say Docker; it says .cloud, because this is pre 2012. And apart from this, I have some use cases and the customer stories, which which tell you about how, let's say, PayPal or Uber uses Docker and how it is helping them to automate and expedite their process.